In the last two videos, I walked through 5 ways a perfectly healthy ML model can silently fail in production. And the very first one was silent data source failure. An external API stops updating, till data flows through your pipeline undetected, and your model starts producing wrong outputs. No error, no alert, nothing. At the end of the last video, I promised we would go hands on. So today, no slides, no theory. We are going to build our actual fix in Python from scratch right now. A data freshness validation layer that sits in front of your pipeline and catches stale data before it ever reaches your model. By the end of this video, you'll have a module. You can drop it into your own pipeline today. Let's build it. So I've got the imports and a small formatting helper already. So we are not burning time into boilerplate. Everything interesting, the data models and the validator itself, we are building from scratch. So here's what we are going to build: a data source class, a freshness result class, and a freshness validator. Let's start with the data models. Source name is str, expected freshness is our time delta, and then get last is our label without arguments. Okay, time. We have a data source class, which is kind of a contract for our expected freshness for any type of data source. So name is our human readable, show up in logs and alerts, not source one, something like customer events API. Then we have expected freshness, which is the contract. How recently must this source have updated? Daily batch job should be like time delta hours equal to 24. If it is hourly, then we should have time delta hours equal to 1 and so on. Get last updated is the bridge to your actual data, a zero argument function that returns the last updated timestamp. We'll see what this looks like in a real pipeline at the end. 3 lines, that's your freshness contract for any data source in your system. Now, let's get to freshness result class. Oops. It's all right. So we have freshness result class, which has source name from which data source this result belongs to, when was the last updated, and when we checked the freshness. Is fresh tells us if the data source is fresh. Staleness tells us if the data is stale. Data is old for, let's say, 3 hours. So that tells us what's the timeline for which data has been stale. Then we have message, which is kind of a safe to log directly, or we can send it to Slack or Teams or whatever we want to integrate with. So you can see here, it is a pure data object, no logic. The logic will go into our validator, which we will build next. We see class, freshness validator. And we say def in it, we have an function, which is equal to none, and then we assign this as alert function is equal to function or self dot default alert. Okay, then we have a check function, self source, and we have freshness result. So here, if you don't pass an error function, it logs the following list of each of the error. You can also go to call select level failability on MongoDB. The validation it just calls the error function whenever there is something wrong with the data. Mostly it's CNS. Explain that check function, which is we want to check any user data source if it was 90% validated. If you don't have any or last update, then we assign it as EBC. Okay, now we get the age is fresh if age is less than or equal to source or class. Expected freshness. Staleness is our time delta of 0 if it is fresh, else age. So if it is fresh, then we'll have a message which will be last updated from activation of page ago and result from that. So I just copy this. Else, if our data source is not fresh, then what we want to do? We want to mark it as stale. Okay, let's go then because last updated saving. And then we have expected within data freshness. Okay, and then we say staleness is staleness. Alright, and again, the result, freshness result of source name is source of name. Last updated result updated. Check it is now is fresh, staleness is staleness, and message is message. Okay, now if not is fresh, then we say self dot. So here you see that we are putting an alert if the data is not fresh and sending the result as object. Else, and if it's fresh, then you're just simply logging a line for the statistical and the are on the result. Oh, it makes sense. I'll just go again. Basically, in the check function, we have one data source against which we are checking if it is fresh or stale. We have now, and then we have last updated from the source itself. If time zone info is not available in last updated, then we are just replacing it with UTC. Then we are calculating the age, and we are calculating if it is fresh based on the contract of data source having expected freshness as the attribute. Then we have staleness, where if it is fresh, then we assign time delta as 0, otherwise the age. Then we are just formatting the message based on if it is fresh or not, creating the result object, and then we are saying if it is not fresh, then we are triggering that alert function which was passed to the freshness validator. Okay, otherwise we are just logging an info message and returning the result. So that's the implementation of our check function. And let's say now if we have multiple sources, list of data source, then we return list of freshness result. Okay, we just say results equal to this for sources. We put in if something goes wrong, then we basically result is equal to self dot check. We say source, and if something goes wrong, we just end that section. And again, we just say now so we are assigning these equal, and then let's say we have error message equal to error source of name put not to last updated stem and the actual error. Then we just log it as another message, and then we form a freshness result for this error. Then we have source name is equal to source of name last updated is equal to date time dot main dot replace is info equal to time don't dot abc. That is copy this because we will need it later. Then we say checked that is now is fresh equal to false staleness. So here we have staleness equal to now minus, and then message equal to error message. Okay, then we say self dot underscore error function of result. We'll append this into our list of results, and then simply again results. So if it is simple, we have all the list of sources, and for each source we check the freshness, and if there is any error or exception occurred in the check, then we'll handle it gracefully and have results inside, and also we alert the function, trigger the alert. Okay, then let's have a all fresh as a function with the same sources, and it will run basically it will check for all sources, and then it will check if all part of this fresh or are in results. And then we have a static method default alert result freshness result. So here we just log a warning. All right. So basically in this validator class, what we are doing, we have check function for single data source, then check all for all the list of data sources. All fresh is something kind of a helper which will help us in checking if all the sources are fresh or not. And default alert is something what we have kind of a default thing if alert function is not passed in the constructor of our freshness validator. Okay, so get last updated throws API is down, DB unreachable. We don't simply crash because we are handling it gracefully. Okay, we treat it as a stale, fire the alert, keep checking the rest. You get a complete health picture of every source in one call. Then this is the pipeline gate. All fresh is our pipeline gate. Basically, if any of the data source is not fresh, then we'll not, we have the complete picture of everything, and it will return false if any of the data source is stale. Good. The module is done. Let me show you what it looks like. wired into a real pipeline. So here we have three data sources. Each has a name, each has a expected freshness and get last updated function. Okay, so here we are just simulating the real world scenario, but you can have this as different microservices or different kind. Each pipeline can fetch customer events, each can product catalog or feature store. Okay, so in a real pipeline, these would be your actual adapters hitting your DB or API. Now, notice the pipeline where before we fetch any data, before feature engineering, before we touch the model, freshness check. So we have this data freshness check. Okay. If anything fails, we stop. The model never sees bad data. Let me run this example. So we have Python examples, pipeline example.py. All right. So here, if you can see, we are starting the ML inference pipeline. We have a step one, which is validating data freshness across three sources. And we have three data sources, as I showed you. Customer events DB, which was last updated 19 minutes or 20 minutes ago. Threshold was 1 hour. Second, product catalog API, you can see this is stale because it was last updated 3 hours ago, expected within 1 hour. Okay, so staleness, we have 2 hour, 59 minutes and 59 seconds, which is approximately 3 hours. Then we have third one, which is feature store export, which was last updated around 10 minutes ago, and threshold is 2 hours. So here you can see like we have aborted the pipeline because one source is a stale product catalog API. Inference will not run. Investigate the stale sources before retrying. Okay, since this is an demo example, we are just showing like if you fix the product catalog API data source as from 3 hours to 1 hour or less than 1 hour, then you'll see that the whole pipeline will run successfully. So let me just fix that and run it again. So we'll go to simulate product catalog API. We'll say UTC minus, and this is, let's fix this by doing minutes equal to 30. Okay, and then rerun this pipeline. And here you can see now we have all the three data freshness checks as fresh, and nothing of them are stale. And here you can see like after step one, we are doing extracting the whole data. Then we are running feature engineering, model inference, writing outputs. So here you see pipeline completed successfully. So what did we just build? A data source, your freshness contract for any data source, a freshness result, a structured output you can log, alert on, or store, and a freshness validator with three methods: check for a single source, check all for all of them with graceful error handling, and all fresh, the one line that sits at the top of your inference pipeline and blocks bad data from reaching your model. The full code is linked in the description. The validator, the adapters for SQL REST file, and Cosmos DB, and the full pipeline example. One question before you go. Does your current pipeline have a gate like this? Drop a yes or no comment. I read everyone. If you want real AI engineering content, production boss stories, working code, no textbook theory, subscribe. New video every week. See you next week.